Alright student, in this video we are going to talk about projectile motion. So what is a projectile motion? Okay, a body that moves in the air under the influence of gravity alone is known as projectile, and the motions of the body is known as projectile motion. That means, example like when you throw a javelin or any other body, if you throw a ball, right, then the ball will go like this. If you throw any object like a stone or anything, then it will take, this is the part in which the object is moving, and this part where the object is moving here is known as its trajectory, and this object in which you throw into the air is known as projectile, and the motions of the object is said to be a projectile motion. Okay, so there are many examples which are related to this projectile motion. For example, like a javelin thrown by an athlete, an object dropped from an aeroplane, a bullet fired from a rifle. Okay, so these are few examples about projectile motion. Fine. So next we will discuss about the projectile motion when a horizontal projection is given. Okay, as shown in this figure, when a body is projected horizontally from a point O with a velocity u, then this body, let's say it is projected at a height h above the ground level. So in this case, the body will acquire two types of motion during its motion. One is the horizontal, another is the vertical motion. So as you can see here, at any point, suppose at any point along this the part of the motion, then we always have two types of motion. One is horizontal and another is vertical. Okay, okay, so I can see here that this body is moving in the xy plane, or I can say in simple words like a body is moving in a plane. Fine. Now at any point along the part of the body, okay, what happened is the horizontal component of velocity, okay, at any point the horizontal velocity is always equals to the velocity which you project the body from the start. That is, it is always equals to u. So at any point the horizontal velocity is uniform. Okay, at this point when you find out the horizontal velocity, you'll find u. At this point u, at this point, at any point you'll find it is u. And along the downward motion or along the vertical motion, this body, it is vertically accelerated downward with a uniform acceleration. So I can see here that the vertical downward motion is accelerated, okay, at a constant rate, which is equals to g, which is the acceleration due to gravity. Because the body, when it moves, as it, right, if you project in this way, then the body goes like this. So it means the body, it covers horizontal as well as vertical. But during horizontal, the velocity, it is always uniform, which is equals to the uh, velocity at the time of projection, and during vertical it is moving down with a constant acceleration which is equals to g. Fine. So because of this, because of the combined effect of two types of motion, horizontal and vertical motion, then the body will move along this part O, P, A. So this is the part which is followed by the projectile. Fine. Now let us see about the trajectory of the projectile. Okay, so now we will look at trajectory of projectile. Okay, suppose at any time t, suppose at a time t, this projectile reach a point P, and this point P, it is at a distance x. That means the horizontal distance is x and the vertical distance of this is y. Fine. So the coordinate of the point P is equals to how much? X comma y. Fine. Now, what is the horizontal distance covered by the body in time t? So I will write horizontal distance covered by the body in time t. This distance is equals to how much? X. Okay, and this x is equals to how much? Is equals to horizontal velocity into time. Okay, because we know from the equations of motion, s is equals to ut plus half at square. So when you use this formula over here, then I have mentioned the word horizontal distance. So this s mean it is x at this point. So this u, actually it is vx in this case. Fine. And then at a time t plus half a t square. And this a, it should be the accelerations along the horizontal component. But as I have already mentioned before, that the horizontal velocity at any point along its path, it is equals to how much? U. And then, so instead of Vx, we write U and then T. Plus, what about Ax? Is there any horizontal acceleration? No. The body is always accelerated downward, not horizontally. So therefore, along horizontal direction, there is no acceleration. So that means Ax is equals to 0. So when Ax is 0, then this whole thing will be 0. So we can say x is equals to just ut, or t is equals to x upon u. Okay. Next, along vertical distance, right? I mean, for the vertical distance at a point P, what is the distance at a point P? The vertical distance at a point P, it is equals to y. Instead of s, we write y. And instead of u, I can say uy. And then t plus half a y and then t square. Right? Next, what is uy? Uy is the initial velocity, which is, or I can say it is the component of the initial velocity along y-axis. So if you look at this velocity, you are projecting the body horizontally in this way. So there will be no vertical components of velocity at the start. So uy is equals to 0. So when uy is 0, 0 into 3 will be 0. Plus half, what is ay? Ay, it is the acceleration in which the body is accelerated downward. So because the acceleration which is produced in this case, it is due to the accelerations of gravity. So therefore for that I will write g. Okay, so this ay, which is the downward acceleration, is equals to the acceleration due to gravity, that is equals to g. So for ay I'll write g and then I'll write t square. Or I can say y is equals to, now this is half g. Now instead of t, I will put x upon u and then square. So when you square, you'll get like this. Okay. Now I will rewrite this as y is equals to g upon 2u square and then times x square. Or I can say, because g here is a constant value, which is 9.8 as you know. And then this u, it is the initial velocity which you are projecting the body horizontally. And this u, it is remaining constant at any point along the path of the motions of the body. So therefore everything here is constant. So I will write that y is equals to, I will replace all these constant value by just a single constant. Let's say that is equals to k, and so we will get y is equals to k x square, right? So as y here, it is a quadratic functions of x, isn't it? Because why we call quadratic? Because the degree of the variable x is 2. So this is a quadratic equation. So that means y depends on x, or I can say y is a functions of the quadratic functions of x. So therefore the trajectory of the motions of the projectile is a parabola. So you will learn in mathematics about parabola. Okay, the equations of a parabola, it is always is equals to like the the quadratic functions of the variable x. Okay, so hence we conclude that the trajectory or the path along which the projectile is moving is always a parabolic path.